to welcome everybody in. Welcome everybody that's here for the first time, everybody that is visiting in and want to see what the ISG community is all about. This is us. We're just laid back learning and sharing and having fun with gemology and loving gemstones. And as we say, sharing the love of gemstones around the world. The other big thing that we try to do is make sure that we make it affordable, that we have the study of gemology to be affordable so that more people can afford it. That's why we're all here. That's what we do. So with that, we're going to give it just a couple of minutes. I'm watching over here. When I look, I try to always look up here. You know, one thing that bugs me, I don't know if you all saw the webinar for NAJA. I was at the NAJA webinar this weekend. Fantastic. So much great information. It was phenomenal. One thing that I noticed about this that is, it's one of those things when you study how to do a webinar, the first thing they talk about is don't talk like this, because right now I'm talking to my computer screen. The problem is you're up here and we're talking down here. So the people spent the whole time talking to us like this rather than like this. And I wanted to get on there and say, we're up here, look up here. So that was kind of fun. But the information in the NAJA webinar on antique appraisals and things was phenomenal. I really, really enjoyed that. It was a great way to spend a Saturday afternoon, and I appreciate Gail giving us the opportunity to invite our community to be there because it was really important. It really was. We're just going to give it a couple more minutes. I did go get a haircut. I had to do that. It's kind of funny. Those of you all do your appraisals. This came up, I guess, because whenever I go to the local barbershop down here, it's a really cool place, but you don't know who you're going to get all the time. And there's always a lot of young people. My hair had grown out a little bit and she was clipping it. I could just see her go, whoa. And she saw this. And she's like, I didn't expect that. And I could tell she was saying, I didn't expect it from an old guy. You know, that's, I told her, I said, no, I've had it for 20 years and it was no big deal. It doesn't hurt anymore. It hurt like hell when I got it. You all have an industrial bar in your ear. The reason I bring that up, it's kind of funny because I was laughing about it. If you're doing appraisal work and you do expert witness work and you're wearing jewelry, particularly the guys, not so much with the girls, but with the guys, because I've had this happen. When I appeared in the federal court cases up in Sherman, Texas, in U.S. federal court, the attorneys were like, there's no way in hell you're wearing that earring in there. You got to take that bar out. And the bar is hard to take out, put it back in. When I went to the district court in Virginia last August, they didn't care. They were like, get up there and do what you do and go ahead. But I just want to let you all know, jewelry wearing by guys in expert witness work can be sketchy, and you may have to adjust to what the attorneys say that they need you to do. So side note, while we're filling up the room here, got 35, we got 4 minutes, we're going to get going. Excuse me. Sorry about that. I try to minimize that. We are in oak season here, and you all know what that does to me. So let's get started. We've already got, you keep freezing my screen. Is it me? I am sometimes called a cold. No, I'm sorry. That's not what it is. I don't know. It's probably Audrey, it's probably the streaming of what your internet's doing. I don't know if anybody else is having problem freeze screening. I've got Tristan here and he will let me know if we've got a technical problem on this side. And usually if I have that, I'll have 30 people write to me and say, hey, this is happening. Well, Tristan already answered it. Tristan, yeah, try to reconnect. Restart your computer sometimes. I restart mine every time. If you don't restart your computer, you need to clear the cache out, the memory cache. And if your memory cache is full in your computer, it can't process everything. And you have to clear that cache. And the best thing to do before the journey is to restart your computer. So just going to let you know that. And there's a couple of things. I want to get to a couple of things because we've got a lot to cover. As usual, I think to myself, oh, we're going to have just a relaxed time this week, and I'll show a bunch of photos. And then at the last minute, I do 40 photographs, and then I add another 20. So just really quickly, those of you that have ordered the yellow apatite, those are going out in the morning. I'm sorry, they're a little bit late from going out. We were waiting to see, to try to get as many orders as we could to ship them all at once. So we're a few days late for those of you that ordered first, and we are filling it in the order that they came in. The biggest ones go out to the people that ordered first. So even if you're having to wait a few days extra, you're going to get the bigger one, and as they go by, we'll. But they all work. Don't get me wrong. They all work. but some of them are bigger than the others. Also, I've got some RI liquid here. I didn't realize I'd gotten from China. We ordered some extra RI liquids. I've got 5 or 6 bottles of RI liquid here that I'm not going to be using. If anybody needs RI liquid, they will be for sale, not for giving away. But nonetheless, we have some RI liquid for that. Next thing is the Ruby video is available now. Last week we did the Ruby video and talked about rubies. That video from last week's is available on the Journey Thru Gemology webpage on the website. I'm having to reshoot the diamonds. At the time that I did the diamonds, we weren't going to provide videos. I am so sorry. I don't know where that came from. Anyway, we weren't going to do the videos, and we decided to, and I'm going to have to reshoot the diamonds. So just a note that on that, the lab created diamond week that we did will be up. It's just not there next. Next week, I think we're going to do tourmaline. If anybody has any specific requests, that's cool. Finally, the Oregon Sunstone trip right now is being postponed. Just didn't have enough interest, and we're only a couple of months away from the schedule of what we had to let the miners know we were coming in for. So right now we're gonna back off from that. Okay, let me see right quick. Silly, I know you got that. I'm gonna hold on the questions for a while. I got some cool stuff to show you. I'm gonna show you all Tanzanite tonight. Some of this like you've never seen before, and we're gonna have some fun with Tanzanite and understand Tanzanite like nobody's really taught Tanzanite. We have a way to do this. And on that note, I'm going to go ahead and take us over to the video presentation, actually the slides, because this is actually going to be fun. I've had a great time putting this together. And let me just start. Here we are. As most of you know, I just want to show this right quick that our article on Ruby, this is based on our meetings. When I do the Journey Thru Gemology with you all on Thursday night, I generally do a newsletter on it by Friday or Monday. And it's always cool because the good folks at Southern Jewelry News pick up our articles and print them. And it's fantastic because it's a big push for the ISG because Mid-America Jewelry News and Southern Jewelry News publishes, they've got a whole series of our articles that they publish up. So you all recognize this probably from last week, and just got to tell you what we're doing here is really having a good impact. I also promised last week we were going to have Greenland Ruby. This is a Greenland Ruby. Let me take this down some. I'm having to get a little, I'm starting to learn this webinar stuff, so I can make this a little easier. Let me take this down. This is the Greenland Ruby. I promised to show you all. It's nothing really fantastic. It's got a couple of nice little ruby crystals. But this ruby is 3 billion years old. It's far, far older than all the rubies in the Far East and Maguk and everywhere else. These rubies are 3 billion years old. That's mica that you see, and also feldspar. So that was a cool thing we're going to do. Also, last week I had people asking about the surface of a glass-filled ruby, and I promised you I would have that, and sure enough, there it is. It looks like, I don't know, it looks like glass that somebody's walked all over. And this, after a glass-filled ruby is worn for a while, this is what the surface starts looking like. And this is you know, a very important tell to identify. It's not going to be like this every time, but a lot of times when you got a glass-filled ruby and there's ruby on and there's glass on the surface, it starts looking like this, and close up, it'll look like this. So I promised you all that I would get this for you. And there it is. Now let's talk about Tanzanite. Let's get down to business here. Let's talk about Tanzanite. What an amazing shot this is. I absolutely love this. I wish I could say I'd taken it, but I didn't. I actually got this from a photographer, and it shows Tanzanite in its most beautiful form, the big crystal, the purple and blue. And this is the classic look for Tanzanite. And this is what it's really all about. I want to talk to you, and I just want to tell you the story of Campbell Bridges, because Campbell Bridges is the one, he was a geologist with Tiffany and Company that actually went there to the Marilani Hills and discovered Tanzanite and helped develop the market. And he is Mr. Tanzanite, he was, I'm sorry that he got killed actually, and I'll tell you about that. But he also, with the Marilani Hills, he discovered the Sabarite garnets, which is what you're showing here. And for the longest time when I was working in the Caribbean, Tanzanites were very big in the Caribbean, very big on the cruise lines, very big in the Caribbean jewelers, and there was a lot of imitation stuff being sold as natural. And I was on a big crusade because I had the Caribbean Gemological Institute at the time. And I was on a big crusade to try to help show that and reveal what was going on. Anyway, I was at the GMA conference in London, and I hear that Campbell Bridges is wanting to meet me. Well, this is kind of like a high school football coach being told that the coach of the Super Bowl wants to meet you, and that's what I felt like. And I went and I met, and it was just so cool because he was such a down to earth guy, and he's world famous gemologist and geologist, and he's just so important to the Tanzanite story. The last time we were in Tucson, he came by the ISG booth to see me, and it was one of these things that Campbell and I could not see each other for 2 or 3 years. I'm sorry. And when we saw each other, it was like old home week. Honest to God, he's one of you all probably have friends like that. You don't see them for 2 or 3 years, and when you do see them, it's like you were with them yesterday. Anyway, I missed him when he came to the booth, and shortly after that, he went back to Africa and there was some kind of uprising with the miners, and for no reason at all, one of the miners killed him. And his son now, Bruce Bridges, is I believe he's just got made president of AGTA. But Campbell Bridges is someone I just wanted to know because he was such an amazing gentleman. What a great knowledge, and he has so much to do with the history of gemstone markets, and you may hear that name again. This is going to be some of our study group tonight. The study group we have for Tanzanite is not, obviously we're not rich, so we're not going to have these big, huge, beautiful Tiffany and Company type Tanzanites to work with, but they are authentic, genuine Tanzanites. And what I'm going to show you tonight are going to be properties that you're going to find in the big, nice, fancy, high dollar ones, because the Tanzanite properties are going to be on all the Tanzanites. And we do have a ton of Tanzanites here, but they're study level, and that's what this is all about. This is the classic Tanzanite crystal. Comes out of Tanzania, obviously. There is a big mining area there. It's cordoned off into 4 blocks and different entities. Local miners get a particular block. The commercial people get a block, and it's just a big old square of land. And this is the classic Tanzanite crystal. They are brown coming out of the ground, but they're heated to turn the blue-purple color. And I got this photograph from Rockhounds. I try to give credit while I can because I don't want people to take our images, so I don't try to take theirs without credit. On the left, you see this is what the Tanzanite looks like coming out of the ground. On the right is after heating. Now, you may hear the term that somebody says, oh, it's unheated, natural unheated Tanzanite that's blue-purple. Well, that's a possibility because of this. And it's the same thing that happened in Brazil with Paraíba tourmaline. Those have to be heated to bring out that beautiful bluish color. If they're close to the surface and there's these big grass fires, well, they're getting heated, and it's being heated naturally. And when somebody goes and digs them out of the ground, they don't heat them, and they can say no heat. Well, it's been heated, but it's not been heated by a person. It's been heated by nature. So when you hear of a Tanzanite that's blue-purple, like this color, and they say, no, it was mined like that, came out of the ground like that, one way or the other, it got heated. And it would be rare, and I'm not saying no because this is gemology and this is a study of exceptions. Remember, it's not a study of rules. It's a study of exceptions. So there could be somebody with a Tanzanite that got heated in underground by radioactivity or something. I don't know. But I will tell you that the ones that when they say that they're natural and they're not heated, they've been heated to some degree, because what they look like on the left is what you're going to be looking for. You're also going to hear the term Block D. It's a Block D Tanzanite, and that's something that that somebody will talk about because this thing got started. Those of you that sell Tanzanite and have been in there for a while know that, well, for me at least, when I got to the Caribbean 30 years ago, I was told, well, the Tanzanite mine's going to play out in 2 years. The Tanzanite mine is almost extinct, and you better buy it now because the price is going to go way up because there's only about 2 years worth of production left. I've heard that virtually every year for the last 30, okay? Same thing, everybody talks about the Block D Tanzanite, that the best Tanzanite, the really finest Tanzanite comes out of Block D of that mining area, those 4 blocks. And I did some research on this before tonight. I wanted to find out as much accurate information as I could. And I got it with some of the people from and Tanzanite's being produced in that whole area. And it's the only area in the world that it is produced, but there's no quantitative evidence that says everything good comes out of Block D. So when you hear this, it's a marketing ploy. You know, it works for some people. Some people, it's like somebody want a blue-eyed diamond. Well, I want a Block D Tanzanite, but there's nothing behind it scientifically to say Block D actually brings out that special quality. But the Tanzanites themselves, you may find them more very strong blue. We're going to talk about this in a minute. You may find them that they're more purple, and I'm going to tell you why that happens. But most of the Tanzanites you're going to see are going to be like this. They're going to be both blue and purple. And that's part of the romance of Tanzanite. That's part of the marketing of Tanzanite. That's one of the things that makes Tanzanite special, because there's not but a handful of stones that will actually give you two colors like this. Tanzanite's one, andesite's another. You know, the andesite will give you a green and brown, depending on how you're looking at it. It can give you a brown and colorless. Tanzanite actually has three colors, but what our eyes can see is the blue and purple. And in the gemstone world, this is extremely rare to have those kind of optical properties in a gemstone. And that is what sets the Tanzanites apart. And they make beautiful jewelry. The stone has a tendency to be a little bit brittle if it's cut too thin. But with the rings set like this, where the prongs, you can see that the prongs are nicely protecting the stones from the top. And when jewelry is set like this, it actually does very well. The Tanzanite pendants, the big pieces, usually go into the pendants and necklaces. But this is your classic Tanzanite. I wanted to start off with this, just kind of talk about the romance and the reason that people want to own a Tanzanite. It's a very unusual stone. It's a very beautiful stone. It has these royal blue and purple colors to them. And that's a property that's extremely rare, like I say, and a property that people are looking for something unique. This all goes back to the pride of ownership. The concept behind all jewelry, for that matter, but particularly colored stones, is pride of ownership and being able to own something that only comes from one place on the whole earth. I mean, there's only one place that it's mined, only one place that it's found, and something that will offer optical properties that are very unique. So Tanzanite is very special, and that's when our first step is the marketing. But what about this blue and purple dichroism? What about the fact that we've got blue and purple, and when you and I are looking at this right now, we're seeing blue and purple. We're seeing it together. Well, how's that possible? First thing, how is it possible for a stone to do that? How is it possible for this stone to generate a blue and purple color? And secondly, how is it possible for our eyes, the little cone receptors and everything else, to go into our eyes and tell our brain, hey, I've got two colors here. Do you see it? And your brain says, yeah, I see those. I got a blue and a purple. And that's very unusual. And we're going to look at why. Dichroism. Let's talk for a little bit about linear polarizer, beam displacer, and quarter wave plate. Or let's not. That looks so damn boring, I can't even stand it. Let's do something different. Let's use a laser beam. Let's put a laser beam into a piece of calcite. I think that's going to be a better understanding of what dichroism is. What you're seeing here, and some of you, those of you that have been with ISG for a while, you know this because I've got this big old chunky somewhere. It's up here somewhere. Oh, here it is. This big old chunk. Just a minute. I'm sitting here talking to myself because I'm still doing screen share. This big old chunk of calcite. Now, the weird thing about this is a calcite piece like this, once I told somebody I had this, I had a gentleman in South Africa write to me and say, you're only about 10 millimeters smaller than the one they used to create the guidance system for the Apollo spacecraft to go to the moon, because the optical properties. That part of it, way above my pay grade, I couldn't even start. But this is just a huge old calcite, and I got this. Those of you that have been in class here, been around ISG at all, know that I paid a fortune for this, but so don't want to drop it. But it's got a unique property because it splits one beam of light into two, which is basically what dichroism is. It's taking one beam of light, or at least the ambient light coming into it, and splits it into two beams. And that is what, look at this right quick. Okay. Sorry, just want to make sure somebody's not panicking and writing to me. That's what we have here. What you're seeing on the left, that is that big piece, and that's a single laser beam going into that, and two beams coming out. The calcite is splitting it. Calcite is very cool for the demonstration because it splits it so wide. It splits it way wide. And in the right-hand side, that's a more recent photograph I took in the dark. The little X thing in between them, I can't explain that because it's above my pay grade also, but the two beams coming through there are very graphic to show you how this calcite is splitting one laser beam into two. Now, what if we had a gemstone that was doing this and it was creating two colors? That might explain how a tanzanite gives us a blue and purple, because the tanzanite could be doing the same thing that this calcite is doing, because it's taking a beam of light going in and splitting it into two colors, and each color turns into one blue and one purple. Let's put a laser beam into a tanzanite and see what happens. Booyah. We get two beams. This is the same laser, and this is one of the tanzanite crystals we have here. One beam going in, two beams coming out. Now, someone that was writing a critique of my report about this said that I was claiming I could put a laser beam into a tanzanite crystal and get a blue and purple color out of it. No, I never said that, and that's not possible. You put laser in, you get laser out. You put one laser in with tanzanite, and this is one of the tanzanite crystals that are here in the office. We put a laser in, get two out. And with tanzanite, if this is ambient light going in, this explains how it turns the light into two different colors, because when the light goes in by selective absorption, it's going to send one of these out as blue and one as purple. Now, once again, these are lasers. These don't have colors. But if it's ambient light just in real life in the room with a nice bright light, that tanzanite's doing basically what you're seeing here with this laser, but it's doing it with regular light. And that's how tanzanite's going to be producing the blue and purple colors. I get so excited about this. I thought about this demonstration. I thought about taking these new photographs about 30 minutes ago, and I've been in this big rush to get these done. I thought I can get better photographs of this, and this is cool. I had to turn the laser upside down, but it was kind of cool to get these, and I thought it was pretty graphic of what tanzanite can do. And all your double refractive gemstones could do this, but they're not always so far apart. You put this into an andesite, it's going to do the same thing, but you put it into a sapphire, it's going to be hard to tell the two because they're going to be so close together. But this is how the tanzanite's going to produce this, and how we can use the London dichroscope in this case to see the two colors. And it separates those two out because of the plane polarized light going through the dichroscope. But this is basically the mechanics. And I realize that this is a very simplified version of it. I like simplified. I like to get technical stuff put down into simplified. I understand it's not big scientific, and I know some people are like, well, I've had a couple of people say, oh, I was expecting something a little more of a PhD level. And I'm like, you came to the wrong place. I like simple demonstrations to explain simple things, or simple demonstrations to demonstrate really convoluted things, because it's so much more fun this way. That first graph would have bored me to tears, and you all would have started tuning out. So anyway, that's what this is. And of course, this photo you've seen, this is one of the tanzanites that we've got. This is how we get this kind of view through the dichroscope. Now, one thing I put this in here, this is a little slideshow in a slideshow right here. You'll notice it is optically directional. You have to remember something. Remember what I told you the last couple of weeks. A gemstone is a 360-degree sphere. It's a sphere optically, and it can come in. What you see the best could be this direction. It could be that direction. You have to turn the stone and look from different ways. Here, you see that if you turn it one way, it doesn't really show that well. But you turn it the other way, it's beautiful. It's a classic tanzanite appearance. So remember to turn that stone. When you're trying to find these dichroic colors with the dichroscope, you've got to turn the stone to get the best direction for viewing that property. It's important. But that is the basics of Tanzanite and the idea behind why you're seeing the two colors. And it's certainly not a scientific explanation, but it's a practical explanation of how that Tanzanite's able to produce those two colors. But we want to take this one step further. Your eye is sitting here seeing these blue and purple, and yet you look at a ruby that may have two colors, and your eye can't see the two colors, it only sees one. But with a Tanzanite, you see two. I think we can have a demonstration of that. First thing is the type of light that the Tanzanite's going to be in. And if you've got a jewelry store, you need to be careful about your lighting. Sorry, I sometimes make these too big. You have to be careful about your lighting, because with Tanzanite, your lighting can really affect the beauty of the stone. And fluorescent may bring out the strong blue, but you're not going to get the really, beautiful separation of the colors. Generally, your incandescent lights, your halogens, are going to be the best lighting for Tanzanite. But in reality, you'll see it's not a color change. And I want to stress that Tanzanite is not a color change stone. It's actually giving you the two colors at the same time. It's dichroic. But different types of light. This is the same stone looking at it the same direction. One is under fluorescent light under the microscope, and the other was just under the fiber optic light I had. But you can see how much difference the two show just because of the different lighting. Now, let's talk just a minute why your eyes can distinguish two colors of Tanzanite at the same time and not see the colors of the other gemstones. This is something that really puzzled me for a long time, which was, just that. I know that some of the other gemstones have two very distinct colors coming out of them, because anywhere you look at a chart for a calcite dichroscope or London dichroscope, there's a whole chart of stones that have pleochroic colors. And why can we see Tanzanite and andesite, for instance, and we can't see the others? And there's a good explanation for that I think will be fun. This is ruby in a calcite dichroscope. And this was one of the rubies we looked at last week. This is one of those big old flame fusion rubies that had been kind of quench crackled. And I only got it because the colors in this really separated nicely. And it looks kind of gnarly inside. You're going to see it in the video in just a minute. But you'll notice if you look at this, you've got a definite orangey red color or a reddish orange, and you've got a very intense red. Those are the two colors that a ruby's going to show. And yet your eyes can't see that. Here's a little demonstration of this in a video. You'll notice that when we use the London dichroscope, it shows when you move the dichroscope, and that's something important when you're using the London dichroscope, move it around, because otherwise you may not be able to see the subtlety of the color changes. But with this, it's pretty incredible because you've got a pretty strong orange on the left and an intense red on the right. And once again, red colors kill digital cameras. The red colors kill my digital cameras, and they just kind of blow up. But this one was important to show because it had the orange and the red, and yet we can only see a red color with a ruby. Our eyes can't see the two. And yet, in Tanzanite, and this moves around a little bit. I had the camera, I had the dichroscope, and I had the stone to move around. So I needed 3 arms, and it sometimes doesn't work so well. But you can see with this, you can see the purple and the blue. It's very clear with this. You see the purple and blue. And by the same token, when you have this, your eyes can see it without the dichroscope. And that's something very unusual for the Tanzanite. And we are headed somewhere with this, because as you can see here with this photo, when I stop this, you've got a blue down towards the culet, you've got purple up towards the girdle. You're seeing both at the same time. And the question is, how can you see both at the same time with this, and you can't see both at the same time with the ruby? And it all goes to this. And let me take this down just a little bit because it'd be easier to see. This is the visible spectrum. This is the visible from about 440 nanometers up to about 770, I believe. But you'll notice on the spectrum, when you put it in perspective on the spectrum, I had to be careful how I say that, your orange and red are very close together. They're very close together. And your eyes see that, and the receptors in your eyes see that, and they're like, oh, orange, red, orange, red, orange, red. And your brain says, make up your mind, orange or red. And you're orange, red. And then finally they say, okay, it's red. It's red. It's a ruby, it's red. So forget about it because it's ruby and red. And forget about trying because they're all so close together, your brain doesn't really separate them out from what they're seeing. But when you get to tanzanite, boom, suddenly you've got a huge separation between the two. You've got purple to blue. And now the receptors in your eyes are going, hey, I've got blue and I got purple. I got blue, I got purple. And the brain's going, you do have blue, you do have purple. And they get together and say, hey, we see blue and purple. With the ruby, sorry, it's too close, we can't tell, so we're just going to call it a ruby red. But with tanzanite, absolutely, we have two. And your brain can keep those apart because they're so far apart on the visible spectrum. I know I'm probably having too much fun with this, but I love this demonstration because it really lets you know why you're able to see these two colors in things like andesite and tanzanite, whereas other stones that are dichroic and may have two very unique colors to them, but they're just not far enough apart on the visible spectrum to be able to separate them. And that's why that case is what it is. Now, let me see if there's any pressing questions. Okay, Tristan, I'll get back to that. Thank you. Sorry, Tristan is my right-hand man. He's the tech. He's the student services, and he's also my tech guy. He's at another location watching to make sure something doesn't screw up or that I don't screw something up. Anyway, now let me just tell you this going into this. What we've looked at now, we've looked at the concept of marketing and why tanzanites are special. We've also looked at the fact of why a tanzanite can give us two colors. And we've also looked at the fact of how our eyes and why can detect two colors at the same time with a tanzanite and not with other stones. But now let's talk about something unique, which is going to be the stones that are used as imitations. And I will tell you this to start this off. Let me get back over to this. There are no lab-created tanzanites. The equation's about this long, and they haven't. Plus, they don't have to. There's so much of the material out there. There's no reason to lab create them, but they would be very difficult, extremely difficult to create in a lab. So you're not going to have any lab created, but you are going to have imitations, and you're going to have some pretty good ones that we're going to look at here. And when I'm finished with you, you're going to be like this, being able to identify them, I promise you, particularly if you have a dichroscope and a Chelsea filter. The main ones you're going to see imitating tanzanite are going to be synthetic forsterite, which is an olivine. It's kind of like a peridot. It's a synthetic version of it, except they make it in blue. You're going to see it. A polysilicate glass. The polysilicate glass, the interesting thing about the polysilicate glass, they take this glass and they put a purple interior and then a blue exterior on it. And it's a polysilicate glass. It's I don't know the exact chemical on it, but it's a glass. But it's got purple in the center or blue, or else it's reversed, and you get blue and purple colors. And it's kind of scary because it'll show blue and purple very much like a tanzanite, except it won't react to a dichroscope. We're going to look at that in a minute. But you have to be careful of all this, but there's some simple tests you can do. But I just want to tell you, the polysilicate can be scary because it sounds like simple, but when you just see one, you're at a show and you see a tray of them or something, it looks like, hey, wow, that's some nice looking tanzanite. So how do we identify them? How do we identify them with what we can carry in our pocket? So you know that's the mantra here. The blue sapphire, it should not be a problem to anybody. I mean, the blue sapphire gets sold a lot because the blue in the tanzanite's often emulated by the blue in a sapphire. But the problem is blue sapphire is probably going to be more expensive. But more importantly, the blue sapphire, anybody that's got a refractometer, it's a simple thing. The RI of tanzanite going to be around 169, 170. Sapphire is 176, 177. And they're so far apart that it shouldn't be a big deal. But let's look at the identifying, and you all may want to make sure that you keep this little chart right here, because this is important, because these are the properties if you have a Chelsea filter and a dichroscope. Chelsea filter and a dichroscope. The tanzanite's going to be golden brown in a Chelsea filter, blue purple in a dichroscope. The synthetic forsterite is going to be no reaction to the Chelsea filter, but blue and colorless in a dichroscope. The polysilicate is going to be a golden brown, which is scary because sometimes they look blue and purple and they react to a Chelsea filter just like a tanzanite, but they have no reaction to a dichroscope. Now, this is something that you need to keep in mind, because I will just tell you this. If you keep this in mind, you're never going to have a problem identifying these. I'm just going to make another point here in a minute, but for right now, I want to show you some demonstrations. These are these stones. Let me take this down again. Sorry about that. I actually make these photos in real high resolution for the purpose of being as good as they can, and it turns out they get a little big. You'll notice here that the two tanzanites, I put two in here. One's a lighter color, one's a darker color. I realize they're included, but it's what we got. And you'll notice that golden brown color is classic for tanzanite. It's just going to be classic. And your polysilicate, they actually dope that to make it turn in a Chelsea filter. They purposely do that. They do the blue and purple layering, and they don't always do it, but a lot of the times they will. And then they dope it to make it react to a Chelsea filter. So if you're looking at it and you say, oh, it's a blue purple stone, it looks like a tanzanite, and you throw a Chelsea filter on it, which incidentally, the traditional tanzanite filter, I know Dr. Hanneman, bless his heart, he's not with us anymore, but he was a dear friend. The tanzanite filter that he and some others have are actually Chelsea filters. And if you see this and you see this polysilicate, and you see the blue and purple color, and you throw a Chelsea filter on it and you see this red color, and you're going to think, well, tanzanite, that's it. But you got to use your dichroscope. The synthetic forsterite's a throwdown because it has no reaction, and you can separate it immediately with a Chelsea filter. But if you start with a dichroscope, it's a different story. This is going to be synthetic forsterite if you start just by picking up your dichroscope. It's got a remarkable reaction. And if you're not careful and really look, particularly at the light, I specifically used this environment. This is not a high light environment. I could really light this up with a fiber optic and just, blow your socks off with it. But this is like if you're at a trade show or something, this is what you're going to be seeing. And that's why I try to shoot all this stuff grassroots level, like we're trade shows, Tucson, whatever else. It's going to be colorless and blue, and that's going to be your synthetic forsterite, and it'll do it every time. I've probably got 10 or 15 of them here, and they all react just like this in the London dichroscope. You have to turn the stone, you have to turn it around and check it in 2 or 3 different directions. But it's very graphic to that. And then, of course, we get to the natural tanzanite. And once again, we've got a very clear purple and blue. And I throw this back in here. This is a different shot of the other stone. I throw this in here just to show you as a contrast between the colorless and blue to the blue and purple. So with a London dichroscope, you should have no problem between tanzanite and synthetic forsterite. One thing that I had some fun with, which I tell this story, I had some people say, no, that this won't work, that you have to have a refractometer and all this. And I was like, no, you really don't, because the properties of tanzanite are very simple. And if you've got a Chelsea filter and a dichroscope, you can identify all of them. Oh, and this guy just went off totally. It's like, no, you're full of crap. You can't do that. And I was like, I'll tell you what we'll do. We'll do a challenge. And I actually have this challenge. Nobody's taking me up. Somebody probably will right now when I don't have the money for it. But I said, here's what we'll do. You line up any 10 stones you want, any 10 blue stones you want. You mix whatever tanzanite you want in there. And I said, you put $100 down, I'll put $100 down per stone. And for everyone you get right, you can pick it up. For everyone I get right, we take the money and we donate it to the Wounded Warrior Project. And I was quite serious. And he wouldn't take me up on it. And then I showed him a couple of examples of this. This works, folks. That's what I'm trying to say. I'm not trying to get cocky about this because I don't go into this because I sure as hell don't have $1,000 spent on the table now for that. But the point being is the dichroscope and the Chelsea filter are all you need to identify tanzanite and separate it from the imitations. And if you practice and get good with that, get some of the synthetic forsterite. They're at Tucson all the time. We got the Russian folks that we go talk to at the Jog show have a ton of the stuff. And get those and practice with them. You're never going to have a problem identifying tanzanite because with a Chelsea filter and a dichroscope, there's just nothing going to be what tanzanite can do. There's just nothing else out there that'll do it. At least not right now. That's not saying never, but at least not right now. So that's going to be an important thing for you to remember because this gemology stuff, it's not rocket science and you don't need the big labs and you don't need a bunch of expensive equipment. What you need is what's up here and what you learn up here and what you can carry in your pocket. That was drilled into me in London, and Ian Mercer was absolutely correct. And every day of my life, I remember it. And I promise you, it works. It's just one of those things that it works if you work it. Okay, in the process of all of this, in the process of studying the tanzanite, because you all know that I've been studying these stones, because we don't develop our course notes based on a book or anything else. We develop course notes based on actual stones. And all these photos you see here are actually from inside the lab. And we teach by experience, not by somebody else's research on Google, certainly not on Google. But something weird came up. Something started happening that was very strange. We started seeing some very weird tanzanites. And of course, here's the thing. When I was doing the Tibet Andesine, I say I, it wasn't I, it was all of us. It was the whole ISG community and a lot of others. The research on the Tibet Andesine, we started finding ways to see the Tibet Andesine to be able to identify it as being treated. And there were some tells. Ted Themelis in Thailand, who's one of the premier teachers of gemstone treatments, told me if you treat a stone, you're going to leave a footprint. Somewhere, if you know where to find the footprint, it's going to be there. Well, we started seeing tanzanites that looked like this. And it was very weird because it wasn't quite right. And then I got a phone call somehow after the Tibet Andesine situation, which is crazy. After I prevailed in the California appeals court against Direct Shopping Network on the Tibet Andesine fiasco, somehow people decided that I must be the police for investigating gemstone treatments, undisclosed gemstone treatments, which is not true because I don't want to do it, and I just tell people please don't, because I've spent too much money, been there, done there, got the tattoo, I promise you. But at the time, I had people that because we were successful with Tibet Andesine, I started getting calls about Pakistani zoisite being taken to Thailand and treated and turned into tanzanite. Well, tanzanite's a zoisite. It is a zoisite. It tests as zoisite, and zoisite is tanzanite. And if they could get color into a zoisite and make it look like a tanzanite, wow, what would that be worth? Like a lot. And it got to be very weird. And so many people called me and I said, look, I'll see if I can find some. We'll take a look inside, see what we can find. And I'll take a look at some tanzanites and apply what we learned from Tibet Andesine just to see. And this is one of the yellow zoisites from Pakistan that I got in. And it got weird because all of a sudden we started seeing, if you notice right here, these lines are coloring that have gone into the growth tubes of this zoisite. And its coloring is not supposed to be there. And on the right-hand side, it's just something weird because this doesn't look like what a tanzanite is supposed to look like. Is this something really weird? At the time, I don't know. It's still really weird, but it's not like anything that I had seen before. So I was like, this goes back to the old geezer rule. If you look at something, you looked at stones for 40, 50 years, and all of a sudden you see something really weird, you go like, wait a minute, what is that? And that's what this was. And then I got more specimens, of course, and we started finding this stuff. And the photograph, you can see 2010. That's how long I've been working on this stuff. This is nuts. That was when it all kind of fell apart because all of a sudden I find this tanzanite, and the photographs on the left were from one particular stone that obviously something was going on. But the one on the right, that was from a tanzanite. It was a pretty stone, but when I got it under high magnification, and I have a Meiji microscope beyond what I have behind me here. I actually have a scientific scope where you put slides and everything else in. It's a very expensive Meiji scope. Get it up to 120, 140 power. I start seeing these tubes full of purple material. And I want you to look at that very carefully, because then we find this, and this was kind of where it all started falling apart, because this photo just tells the world about what's happening. The green is a chromium oxide that's used to polish gemstones. And we see that a lot in surface breaking fissures and in any kind of a surface breaking tube. We see this green chromium oxide because it's used to polish stones, and it's a residual. It gets in there, and you can see it in this tube in the front. But going back about halfway, you see that tube, and the chromium oxide only goes so far, and then all of a sudden you have purple color, and then it just bleeds off into the stone. And this is not natural. This is not something that should be happening in a tanzanite. And this is where the wheels came off, because as you all know, I'm pretty well versed with looking at these things. And of course, the photograph on the left was the red dagger. We call it the red dagger. When we found that, we knew we could prove. Now, to this point, people were saying that me and the ISG community and a bunch of other people were totally nuts because they were saying feldspar could not be diffused. And this photograph totally changed that. And then Dr. Emmett came out and he did a full scientific evaluation, which he did fantastic, and actually proved that feldspar was very easy to diffuse. And then Ted Themelis contacted me and he said, let me tell you something, Robert. When we could get beryllium into sapphires, we knew we could color enhance any stone, because getting beryllium all the way through a sapphire meant they could get any coloring element inside. And there's a patent for coloring garnet that goes back like 30 years. They've known they could do it for a long time. It's just that it's hard to find, because the key is if the treatment works beautifully, they're virtually impossible to identify. But it's the little things in it that don't quite treat properly, which is what makes it happen. But applying the basic concept of what we'd seen in Tibet Andesine, I started taking photographs of the tanzanite because I knew from what Ted told me that there was going to be a footprint. I made a little bit of a mistake by sending the photographs and the specimens to the Tanzanite Foundation, which no longer exists. And my first thought was, well, the Tanzanite Foundation would want to know about this and find out. That wasn't the case. Tanzanite Foundation didn't want the subject to even come up. They didn't want the subject to come up that tanzanites could be color enhanced, or that some of the stones being sold as tanzanite could be color enhanced. And it didn't go well, in spite of the fact what I sent them, until I had these photographs you're about to see right now, which is going to be sliding into home plate here. I started finding photographs like this, particularly in the big microscope, of color elements in fissures deep within the stones. And this particular one right here, when I showed it, because this was a yellow zoisite that didn't treat properly, but obviously had been treated, then they couldn't say anything else. I mean, there was not much to the story. And I'll go through these here because there are a lot of this, and I want to take some time so we can have some question and answer time. But you can see here, these are graphic that somebody's doing something, okay? You don't have to show just a huge amount. In other words, it's not something you have to show that, oh, 20% of the market's like that, because that's not what this is. A very, very small amount is out there. But people are treating the zoisite, the yellow zoisite from Pakistan, and getting it to turn purple. It may not be that great, you know, a trained gemologist is going to see this and say, oh yeah, that's what this is, and no big deal. But think about consumers, and think about jewelry store owners that don't really have any training, and dealers who may or may not be aware of it. And all of a sudden you've got an open path for the market. And we as gemologists need to be aware of this so that if they come to us, we can be able to spot them. That's why I show you this. Not trying to raise alarm. I'm not even saying there's a ton of the stuff out there, because I don't think there is, but it's out there and you need to be aware of it. This was hard to photograph. This was hard to focus on. It was a tube that's just full of purple stuff. And then this is the one that really told the story, because this was a tube that just full of this colored material. And how this all goes into creating colors and things, I don't know, because we couldn't afford. I wish I could afford LAICPMS on this, or X-ray fluorescence, but I spent $60,000 on tibetan-andesine, so there was no way I could get into this and start spending money on it. But this was a shot right here that Tanzanite Foundation and nobody else could answer for, because when they saw this, there's only one. This is a big tube, and tanzanites will have growth tubes in them. And this was a tube that was just full of the coloring material. And they finally had to admit that tanzanites are being color enhanced, or at least the zoocytes are being color enhanced to try to make them turn blue or purple to emulate it. And of course, when you put one on the refractometer, because it is a zoocyte, it tests as zoocyte. And if they can get it purple enough, it'll be called a tanzanite, even though it's really not. But these are the things to look for. And if you know these things to look for them, it'll be easy for you to identify them if you see them. And this was the final one. This one, I'm sorry, this is so big. I gotta start making these smaller. This was the one at the highest magnification that actually showed that the stuff had granuled up into the thing itself. Now, once again, I want to drive this home. The odds are very low you're going to find one of these, but they're out there and you need to be on the lookout for them. I in no way want to start getting anybody all concerned about the tanzanite markets or anything else. That's not the purpose. I do want you as gemologists to have this in your toolbox, that when you're doing an appraisal on a tanzanite, it's just simply something in your steps of identification and verification that you use just to double check. The odds of you finding one are low, but the odds are out there that you may see one and you may find one, whether it's buying, selling, appraising, they're out there. And it's something that you just simply need to know in case you see it. And once you see these photographs, it'll be no problem being able to identify. That is the story of tanzanite that we can cover in 1 hour. We've looked at the marketing value of tanzanite, and we looked at the optical properties of tanzanite. We looked at how it can generate the two colors. We've looked at how your eyes can identify those two colors. We've looked at how to identify very easily the imitations that may be on the market, and we've looked at some of the stones that may be treated that you may run into and give you an idea of what to look for. And that is what this is all about, is being able to give you more tools to work with to be successful in your career in gemology. And the reason that we've gone back to the Journey Through Gemology concept, it's added a huge workload to me, but to be honest with you, I'd rather be doing that than the other stuff. So this has been a lot of fun for me, and I hope for you also. I want to take a few minutes right now.